I'm just going to finish up the notes from parallel and perpendicular lines. So where I left off, we had perpendicular to the line y equals negative 3x plus 7. So perpendicular would be positive, and if you flip or take the reciprocal of 3, it's going to be 1/3. So y equals mx plus b. We're going to find that new y-intercept. So y is 5, m is 1/3, and x is 3. The 3 divided 3 is 1, so you're left with 1. And minus 1 to get 0, so 5 minus 1 is 4. So b equals 4, and so y equals, the m is the 1/3, and our b number is 4, which looks pretty close to what it is when I graphed it over here. So that makes sense. Let's do another example, parallel and perpendicular. So on this one, if I were going to graph it, just a rough sketch of this. So up at 7, up 3/4 might look something like this. And through the point 9, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 1. So maybe the point is about here. And so what we want to do is we want a point through here that's perpendicular. It looks like I need to extend this a little to get a line that looks perpendicular to that line. So if you notice, it looks like our y-intercept is going to be a fairly large number because that line's going to keep going, and to hit the y-axis, it's going to be pretty high. So that's what I'm going to look for when I go and I find the y-intercept. I'm going to see that it is going to be a pretty big number. So here, this is y equals 3/4 x plus 7. So we know that we need perpendicular slope to 3/4. So that means we need negative, which is what this line is doing. It's going down. And if you flip 3/4, we get 4/3. So that's the slope for perpendicular. So we'll have xy. We need to go through that point. So y equals mx plus b. We get 1 for y, negative 4/3, and 9 plus b. 9/3 makes 3. 9 divided 3 is 3. And negative 4 times 3 is negative 12. You can use your calculator if you don't know how to times a fraction. Or you just times the top and divide the bottom. That's another way to multiply it out. I just divided first and then times the top. So on here we add 12 to both sides. And so b is 13, which I expected it to definitely be bigger than the 7, but maybe I could have made my line a little bit more accurate. So on this one, our equation that's perpendicular, we've got negative 4/3 x, and our y-intercept, our new y-intercept is 13. The last example I'm going to do of this, so we want to go through the point 0, 0 to the line negative 4. 1, 2, 3, 4. And negative 2/3, so down 2/3 might look something maybe similar to this line. And if we want to go through the point 0, 0, we're going to have some kind of line looking like that. So we have y equals negative 2/3 x minus 4. And we need to go through the point 0, 0. So our slope is negative 2/3. So if we want perpendicular slope, it's going to be positive, and we need to flip it. So it's going to be 3/2, 3/2. That's going to be the slope. We need to go through the point 0, 0, which actually is a y-intercept. So I could just tell you that the equation is just going to be 3/2 x and then plus 0. But let's just plug it in so that we make sure we know how to do it. If we plug in the numbers. So y is 0, m is 3/2, x is 0, and we're going to solve for b. Anything times 0 makes 0. And if we minus 0, well, b is still 0, like I said. So here I don't need to put plus 0, I just can put y equals 3/2 x. And that would be the equation of the line perpendicular that goes through the point 0, 0.